All right, so the last of our proper lectures for this course. I was saying to my last class, it's been both the longest and the shortest semester in quite some time. I'm not quite sure how it's already December, but also it feels like we've been here for quite a while. So today we get to wrap up on the topic of problem solving. So we're going to talk about some of the approaches to problem solving, some of the ways that we evaluate information when we're trying to make decisions, as well as some of the pitfalls that we need to keep in mind when we think about solving problems. But we're going to start off here with a couple of terms, the first being the idea of the problem space. And this is the set of possible pathways to a solution that are considered by the problem solver. So basically, when somebody sets up a problem, especially the ones that we've been looking at, where they're experimental situations and they've been set up with certain restrictions and certain sort of rules that guide what you can and can't do, the problem space would include all of the possible solutions to get from the start point to the goal. So when we talk about a problem space, we're just talking about all of the things that you can work with, all of the different ways that you can get from A to B. And we can do that A to B through two different means. The first being algorithms. So an algorithm would be a methodical, systematic, step-by-step approach where you try all possible alternatives while you search for a solution to a problem. So this would be trial and error. So if you're given, maybe we have that orc and hobbit problem from before, and you're not quite sure how to get from the beginning to the end, but you can try a bunch of solutions and then restart anytime you get stuck. That would be an algorithm where you're trying those sets, and maybe you have a particular approach. Maybe you follow a set of rules so that you make sure that you check all possible solutions. And algorithms are great because they give you the chance of a guaranteed solution. Because you're going step by step, you're going to be following some kind of systematic process, you're going to try all of the possible outcomes. And so you're going to get there in the end, the downside being that it might take you quite a while. So this is kind of like when we were thinking about our static, unchanging automatic processing versus our adaptive and more sort of free thinking, whatever the opposite one was. I'm having trouble with words today. So it's automatic versus, nope, that's going to be gone for now. But you will remember the concepts. And again, we have that issue where the one where we are thinking about and have that freedom and flexibility is also more mentally taxing. So algorithms are going to take a lot longer to get through because you're not sort of automatically hopping to the right solution. You're trial and erroring this until you get the right answer. So you're going to be brute forcing it. And so an example of one of those types of problems where we might be using an algorithm or we might use something else are these tower problems. So you've probably seen these before. They have the 3 pegs and 3 rings on those pegs, and there's rules in place. You start with all 3 on peg A, and they want you to have all 3 on C, but there's the caveat that when you move them, you can only move one at a time, and you can never place a larger ring on a smaller ring. So you can put 1 on 2, but you can't put 2 on 1. And so they say they want you to get that tower from A to C without violating any of the rules. So what process could you use to go there? So you could start trial and error. Well, okay, let's move 1 to B, and then 2 to C, and then where do we go from there? So you can try all the possible combinations. What we might use instead are heuristics. So heuristics are shortcuts, maybe guiding principles or sort of gut instincts of how to try and approach a problem. So they can be very general rules of thumb that we can use to try and approach the problem in a useful way. The problem here is that heuristics aren't a guaranteed solution. They're something that's meant to be sort of quick and easy with minimal involvement. You don't have to go through every single step like with an algorithm, but the drawback being that you can't be sure you're going to find the right solution. And so there are lots of different possibilities for heuristics. We can have lots of different approaches that we can use. Maybe we can set up sub-goals, break it down into smaller pieces, and then solve each one independently. So maybe with that tower problem, we think about, okay, first problem is how do we get 3 all the way to the far side? Then we'll figure the rest out. We might try and work backwards. So knowing where we have to end up, can we get to the middle? Can we approach this problem from both sides and hopefully get somewhere the same in the center? We also typically search for analogies. So we try and look for solutions that have worked on previous problems to see if they would apply in the current problem. So that's going to make you think a little bit of our mental sets that we've already discussed, where we can sort of assume that the solution is going to be the same as a similarly presented problem that we've seen already. It can be beneficial because, yeah, we found a solution. The drawbacks to the mental sets were that we might ignore more efficient solutions, but sometimes just solving the problem is enough. You don't need the most efficient solution, just solving it is fine. So relying on mental sets would be a decent heuristic. All right. So the next thing that we might be doing is changing around how we represent a problem. So for example, you might have seen problems kind of like this one, where they have 2 moving vehicles and they start at a particular point and they move at particular speeds in opposite directions. And then you have to figure out something about their position relative to one another. And maybe they throw in a 3rd moving object just to make it harder. All of that information in that form is mostly just confusing. But if you were able to represent all of that information as, say, a bunch of equations, maybe you can put together some equations on what's the distance that's being traveled, how does this relate to that, can we sub in variables in order to solve this like a mathematics problem. That representation can actually take it from something that's too complex to imagine to something that's a lot more manageable and potentially solvable. And so we can represent different problems in different ways, and usually we're going to be doing that based on what we're familiar with. So if you've taken a lot of math classes, or if you've done a lot of physics where they represent sort of speeds and distances in equations, that might be really useful to you. And then another thing that we want to consider is the benefit of taking a break. So this is that incubation period. And it kind of ties into our discussion earlier where we talked about insight, where you get to that aha moment. And in fact, insight sometimes follows incubation periods. So when you're working on a problem, maybe you're trying to solve that train problem, and you've been squinting at equations all night, and you're just really frustrated with it, so you take a break. Maybe you decide to go make dinner. Maybe you go take a walk, have a shower, whatever. And while you're doing something else, the back of your mind can still mull over some of that information. And sometimes, while you're doing something completely unrelated, is exactly when that solution pops into your mind. So you have that moment of inspiration after you've incubated that information. And we could say that incubation might be part of what's happening while we're sleeping. So maybe while we're dreaming and maybe reliving some of the events we experienced during the day, our mind might be mulling over information that we have available to us. But a lot of people point to incubation as being a very important process in this problem-solving steps. I find I have a lot of solutions to issues with experiments while doing things like washing the dishes or swapping out the birds' cages or whatever. I find it's a mindless task that frees me up to think a lot about other problems. All right, and then another interesting topic that we can talk a little bit about is sort of some of the cultural differences on how we tend to represent or frame some of the problems that we're faced with. So we had mentioned earlier that some of our approaches might be very heavily influenced on experience. So the way that we can divide things up is based on our experience with all of those different categories. I had been talking about classifying colors as artists versus non-artists, and how that might override any effects of classifying colors in languages that have sort of large versus small descriptors for different types of colors. But here we can also talk about how we frame things sort of on a larger scale. So we can specify between field dependence, where people rely on external frames of reference. So this would be when you depend on things in your environment in order to represent or frame or consider different ideas. Or we might have field independence, where we don't care about the environment, we instead frame everything with internal frames of reference. And what we typically find is that Western cultures tend to have more field independence, meaning that they have a lot more reliance on internal frames of reference. So I like using the example of navigating here. So if we think of an internal frame of reference, if I'm navigating, I would think in terms of, okay, well, I turn left here, walk this far, turn right, walk another bit, turn left again. So I am orienting myself to my own position in the environment at the time. And if we think about it, if you were looking at, say, a video game and you were looking sort of top down on that individual, or maybe even coming up sort of over the shoulder, the environment seems to swing while the individual stays still. For the field dependence, those who rely on external frames of reference, instead of having that camera follow the character, the camera would be looking at the whole map. So this is when you navigate using things like landmarks. Maybe use the cardinal directions. So you know that you have to go north and then east and then north again. So you're not necessarily thinking about which direction you need to turn at each of those points. You're just considering where in the city you are. So you're having a much bigger frame of reference. And there's quite a bit of debate here as to whether or not that's something that's consistent. From my own experience, I've taken a couple of higher level courses on navigation especially. There are ways to get people to use sort of more internal or more close to the body references, or more external or more distant points of reference, depending on experience and the reliability of different cues. So we're actually capable of doing both. We just have a tendency to rely on one versus the other. And there are some arguments that this isn't exclusive to navigation or problem framing. This might just be that idea of holistic versus individualistic cultures, where holistic cultures look at the whole picture. They consider how things would affect the whole group, how the larger effects would be on everyone else, not just the individual, whereas individualistic cultures, which are typically Western cultures, they tend to focus in on individuals and how this affects me and that sort of immediate outcome. So a couple of possibilities there. All right, and so next we're getting into, okay, so how do we actually make these decisions? So we've talked about framing, we've talked about some of the considerations in the background. How do we actually go about making these decisions? And so we're going to see fairly quickly that with humans, a lot of our decision-making strategies are fairly simplistic. And we're going to see that this simple approach actually leads to a lot of illogical or even irrational choices. So if we consider something from the probability of an event, we might expect one decision, but we'll see that people tend to make a completely different decision because they're using other information, and sometimes very simple internal algorithms to determine what they're going to do. So a lot of the ways that we try and model these decision-making processes are using either additive or eliminative decision-making models. So basically, in an additive model, you'd be making choices by rating the attributes of each alternative, and then selecting the alternative that has the most desirable attributes. So you'd consider all of your possible options. Maybe you make a pro and con list, and you're going to focus on which one has the most pros, which one has the most benefits to it. That's typically what we use when there are only a couple of options available to us. When we have many, many options available, we go with the elimination method, where we look at sort of the negatives. So let's get rid of things that are sort of unattractive alternatives. So we'll get rid of choices, we'll exclude things if we don't like that option. And sometimes we'll use a little bit of both. But that's usually how it's framed. And we'll see that in a couple of slides when we talk about things like behavioral economics, looking at the economics of people making decisions, how it affects outcomes and things like that, because a lot of that's represented with equations trying to model behavior. It's also important to be aware that there are quirks and complexities to human decisions. I've been using the examples of strange situations I've encountered, say working in a lab. If you've ever worked in a research lab, you might have seen a protocol that has some weird notes scribbled in the margin. I've encountered ones that say when you're making the media to grow cells, you have to stir it 3 times clockwise and once counterclockwise, but no more. And if you ask them why, they'll say, doesn't matter, just do it. And the way that this arises is usually there was a situation where something went wrong, they had a lot of problems, their media wasn't turning out, and then by chance, someone did it that particular way and it worked, and they went, okay, this is the only way from here on out that we can make media going forward. I've also encountered the fact that you only use the machine on the left because the machine on the right is temperamental, and you can only use it if you do this particular action. And none of them are usually related to science. They're just superstitious behaviors that have ended up evolving over time. I've also seen this outside of the lab. I've seen it in, say, office buildings where we have procedures that are very convoluted and circular, but nobody changes it because, it didn't work in the past, so we never want to try it again. So there are all these weird complexities and things that can affect the actions that we choose to take that you might not realize. So people can have superstitions for reasons, and it will change their behaviors. I just always find it hilarious to go into a new lab and see which superstitions they all have, because they definitely exist. All right. And then, of course, when we're thinking about decision making, we've just been talking about sort of general decisions, but a lot of the research on decision making has specifically looked at taking chances or making risky decisions. And so I talk quite a bit about Dr. Marcia Spetch. She works at the University of Alberta. I've taken classes with her, and I've actually gone to conferences with her. She is a lovely individual, but her research areas overlap extensively with what we get to talk about today. So she looks at decision making, but also gambling in humans and pigeons. She also studies navigation, which is kind of hilarious because she has no sense of direction and someone always has to go find her. My first introduction to her was her telling a story about getting lost in the desert for 6 to 8 hours and only finding her car again because she backtracked all of the photos she had taken on her way out into the middle of nowhere. And apparently this is common. She's done this a couple of times. But she's fantastic. She's done work all around the world and has published immense amounts of research, but is also just a really cool person. So I talk about her in this class because when we talk about risky decisions, I always think about her working with pigeons. So she has pigeons in operant boxes. They now use touch screens. They used to use buttons, but she'll have an operant conditioning setup where there's one button where if you press that button, you get a guaranteed payout. So the pigeon is guaranteed to get 1 food pellet. Then the other button is going to be a risky decision. So they might get 10 pellets or they might get no pellets. And they can set up the program to sort of vary the probabilities. And we can look at what point does the pigeon sort of decide that they should only take the sure win, and at what point should they always take the risk. And so if you think about it sort of mathematically, the always win, you're always going to get one. So if the gamble is sort of a 1 in 10 odds, so every 10th press or so you're going to get a payout, then the payouts are going to be about the same, and we should see about an equal split between the buttons. If there is sort of lower odds, if it's say 1 in 20 or 1 in 100 that you'll get that big payout, you're going to be more likely to go with the sure thing. Theoretically, there are ways to bias the pigeons to prefer one or the other, and we'll actually talk about some of our weird ways of framing things that make us more often going to choose non-optimal choices. But when we're doing this, when we're trying to weigh these options, we might be looking at the expected value. What is it that we are likely to get? So 1 for sure, or 10 at what odds? So if it's 1 in 10, then the outcome should be about the same. But if it's a lot less likely to happen, then that outcome should have a lower value, theoretically. We also have the subjective utility of the situation. So if we have a really hungry pigeon, they might be content going with the one sure pellet every single time. They don't want to risk it when they're already hungry. But if they have tons of food, they're at the end of their trial, they really don't care. Yeah, they might try the risky option to see if they happen to get more food. So their weighting of that outcome can affect what they choose. And we see this in humans. We'll base our behavior. We're more likely to sort of risk it for something that we want. But it's also going to be about framing. And we'll talk about that, I think, in the next couple of slides as well. It always comes back to framing. We also have this issue of subjective probability. And this is basically saying that we have to have sort of an internal evaluation of what is it that we think is going to happen. And we keep in mind the fact that we're actually really bad at estimating probabilities. With the pigeons, we give them the 2 buttons, and they can figure out the guaranteed one pretty easily. The probability one, they don't really make a difference between, say, 1 in 10 odds versus 1 in 9 odds. They're going to look about the same. And the same with humans. If you give them situations where they have to figure out the odds, we tend to overestimate the occurrence of good events and underestimate the occurrence of bad events. So we would think, oh yeah, we always, or every couple of presses, we get extra food, even if it's not that common. So we're really bad at judging probabilities, which we'll see a little bit later on. And we'll even mention the framing of something being a good outcome versus a bad outcome can also shift how we consider things. So it's a very complex process. And so when we're trying to judge these probabilities, the fact that we're very bad at it, there's a bunch of different explanations for that. And so here we have a couple of different heuristics or shortcuts that help explain why we're so bad at judging probabilities. So the first is the availability heuristic. And this is when we're basing our estimated probability of an event on how easy it is for us to recall that event happening. So this can depend on a whole bunch of things. So if we think about, okay, we're asked how many people or what's the proportion of the population that are divorced. And so we think about it and we go, okay, in my friend group, there's 10 friends and 6 of them have divorced parents. So, okay, 6 out of 10 have divorced parents. That would be my estimate based on what's available to me. And that may or may not be accurate. We can talk about the fact that that's a very small sample and we're generalizing to a very large population, which is a bad course of action. But we can also talk about the fact that some things are more easy to recall. So that's when we bring in this idea of salience. And we mentioned salience when talking about sensation. So some stimuli are just more attention grabbing. Maybe they are brighter or bigger or louder, and they're going to grab our attention. And the same thing applies for events. So if you think about shark attacks, if we were asked how many people die every year due to shark attacks, especially right after there has been a shark attack and it's been in the news and everyone's been talking about it, we're a lot more likely to overestimate that event, even though it's very unlikely, just because it is so attention grabbing. Whereas if somebody asked, okay, well, how many people a year die because of cows or vending machines, we would say that those numbers should be much smaller, even though many, many more people die to cows and vending machines than they do to sharks. But that availability heuristic will sort of twist our assumptions based on how we frame information. We also have this representative heuristic, and this is when we base the estimated probability of an event on how similar that event is to some kind of prototype of the event. And this is kind of a weird one, and it's a very wordy way of saying it, but typically when we consider this, it's situations where they have an individual and they say, out of 100 people, what are the odds that this person fits this particular role? So a lot of them will be, what are the odds that this person is a librarian or that this person is a mechanic? And they might give you information like, in a general population, 1% of the population are librarians and 1% are mechanics. But then if they show us an image of somebody who looks kind of like a librarian, we suddenly seem to forget that base rate, that 1% of the population, and they show us Steve. And Steve looks kind of like a librarian, and so we're going to say, oh yeah, no, the odds that Steve is a librarian are like 20%. Even though he's 1 out of 100, and we know that there's only a 1% chance of being a librarian, we're going to overestimate for Steve because he looks like he fits that particular role. He might be a mechanic who's just cleaned up to go out on the town or something, but people have that sort of inherent bias. And that shows off our tendency to ignore base rates. So if we're told the base probability of a particular event, we can understand that concept and then completely disregard it when we make our own decisions in future choices. So even if we know that there's only a 1% chance of being a librarian, if 2 people look like librarians, we're going to say that they're both librarians. So we can ignore some information in the favor of gut instinct. And we also have what's called the conjunction fallacy. And this is this weird setup where when we know that 2 events are fairly unlikely to occur, when they occur together, we actually frame them as being more likely at that point. And so if we consider this just from probability, so we have Steve has a 1% chance of being a librarian, and then we'd also say that there's a 1% chance that someone in this group is from Ireland. And we've only seen him, we haven't heard him say anything, so we have sort of 2 events that are only 1% of occurring. And if we were going to do the base probability of what if we say that, okay, what are the chances that Steve is both a librarian and Irish, we'd actually have to multiply them together. So we'd have our 0.001, and then multiply it by 0.001 again, and then we would get something with a lot more zeros, a much less likely thing to occur. And so then we would have, say, a 1 in 1,000 chance of him being both. But people would estimate the odds of him being both a librarian and Irish to be much higher. They might even say that now there's a 2 or a 3 or a 5% chance, especially if he looks like he fits in any of those groups. So if he has red hair or glasses, they're going to overestimate the likelihood of those events, even though the likelihood of them co-occurring should actually be very low. So this is more of us saying that people have this sort of disconnect between probability and logic and how we make our decisions. So we might know this information, but we don't always consider it when we're making our choices. All right, and I did hint that we were going to talk a little bit about behavioral economics, and this is a field that examines the effects of actual human decision-making processes on economic decisions. So we can use models that would represent human choices and look at things like, do people choose to buy or sell? We might evaluate looking at stocks, or when people buy things, or how much they buy. And this is really useful because we have this theory of bounded rationality, which ties into what we talked about before, where we said that people use very simple strategies when they're making decisions. And we do this because we typically focus on only a few pieces of information. We tend to ignore vast majorities of the available information, things like base rates, and we rely on those heuristics, those shortcuts. So we'll focus in on a subset of information that may or may not be helpful in making that decision. So this is really beneficial because it allows economicists, people who do economics, they can focus in on fairly simple equations to try and model these behaviors. And of course, we can all bring this back to the idea of framing. And I think I hinted at the idea that if something is framed as a benefit versus a loss, we're going to change our decisions. So if we ask the exact same question, and in one way, in one group, we tell them that, okay, so we can save 80% of the population. Would you make that risky choice? People are more likely to say yes than if you frame it as, we will lose 20% of the population. It's the same numbers, 80 saved versus 20 lost. People will disagree with the negative framing and agree with the positive framing a surprising amount of time, even though it's the exact same information presented. Another way to see this is in Nova Scotia, where I learned to do most of my driving. They actually regulate the gas prices across the province. And so to stand out, some gas companies will advertise a discount for people who pay cash. What they're really doing is when people pay cash, they now don't have to pay a surcharge to use credit cards. But if they framed it as this is the price of gas, and if you use credit cards, you have to pay more, people dislike that because it's losing more money. They would rather save money as gaining something. So that positive versus negative framing can dramatically influence people's decisions, even if it's the exact same situation presented two ways. And so the next slide, I actually found this really, really cool because the text took a moment and talked about this book called Thinking Fast and Thinking Slow. And it caught my attention because when I took one of Marcia Spetch's classes, first off in my grad school career, she made us read this text. And I actually looked on my shelf and I still have this book within arm's reach from my desk where I do my recordings. And so this book actually talks about sort of the dichotomies of how humans process and consider information. And we see a lot of sort of parallels with what we've talked about with that automatic processing versus effortful processing, which has decided to come back into my brain now. But we have sort of that idea of, yeah, we can have shortcuts. We can have things that aren't necessarily guaranteed solutions, but they're quick and easy and not resource intensive. Or we can have the slow process. We can evaluate all the possibilities. We can go step by step, but it's going to be really time consuming and really resource intensive. And so some people would point to human decisions and say, well, our reliance on heuristics, our shortcuts, and our assumptions, it's really non-optimal. It's really, really frustrating. It's inaccurate. It's maladaptive to make these incorrect choices. But the other side of the field will point to it saying that a lot of the experiments that test these abilities are actually very artificial. Most of these tests, as I said, are people sitting in front of a computer and clicking one button or another, or having to choose between two different lotteries with different odds, or anything like that. So those are very artificial situations, and humans would have evolved their decision-making processes when they were surviving in the real world. So when we had to make decisions while hunting and gathering, that's when this stuff would have evolved. And so if we think about it, in the moment, when there are time constraints where sort of dithering over a decision could mean that you're standing there to get attacked by a wild animal, quick decisions might be better, even if they're not optimal. A quick and dirty solution with our heuristics would be better than doing nothing or wasting time or wasting resources to find that optimal solution. So if we frame it that way, it kind of makes sense that, yeah, these apparently maladaptive approaches probably came about in a different situation, in a different environment, and when we frame it that way, they're not as maladaptive as we think they are. All right, and that brings us to our very last slide, where we try to understand some of the pitfalls in reasoning. So we're focusing in again on the fact that we have these biases in how we approach information. The first is the gambler's fallacy. And this is the belief that the odds of an event is going to increase if that event hasn't occurred recently. And so it's called a gambler's fallacy because we can frame it as somebody who's gambling. Maybe they're sitting at a slot machine and they're pulling the lever and they've been there all afternoon, but they don't want to leave, they don't want to switch to a different machine because there hasn't been a payout in a really long time and they're due for a win. But if we understand probability again, every single time they pull the lever, it's the same odds of having a win. So each time is a 1 in whatever chance of getting a payout. Whether they've been sitting there all afternoon or whether they just sat down, the odds themselves don't actually change. In my last class, I used the example of I have a fairly large family and they tend to have lots of kids. So one of my cousins had 5 boys and they wanted to have a girl. And so they were saying, well, we've already had so many boys, we'll try again. The odds are we're absolutely going to have a girl this time. But by probability, each child is a 50-50 chance of being boy or girl. Yes, it was overall unlikely that they happened to have boys 4 times in a row, but it's not unheard of because it's just a 50-50 chance each time. Their 5th was a girl, but their logic for trying again, a little bit shaky. So that would be the gambler's fallacy. We also have the law of small numbers, and that kind of harkens back to what I was saying about using a small sample to expand or make assumptions about the larger population. So if you're using your friend group of 10 people and making assumptions about how that relates to all people in Canada, you might have some issues. And that ties back to our Chapter 2 discussion about having a representative sample. The smaller your sample is, the lower your odds of it being representative are. That's just because with small numbers, the probability of getting a non-representative sample just goes up. So even though we make these assumptions that, oh yeah, from my experience, from what I've seen, this is totally how it is everywhere, we can't necessarily make that conclusion unless we have some way of showing that it's a representative sample. Humans are also really bad at we overestimate the improbable. And I think a lot of this is to do with the fact that it's very difficult to conceptualize how unlikely some events are. So lotteries are a fantastic example of this. So you can talk about winning the lottery is less likely than being struck by lightning, but we don't realize how unlikely it is to get struck by lightning. It's very difficult to frame how unlikely that is, and then even harder then to think of something being more unlikely than that. So we're really bad at visualizing very small numbers. We're bad at visualizing probabilities, period. We're also really bad at visualizing extra large numbers, but that's a separate problem. It's more along the lines of human estimates tend to be very inaccurate for a variety of reasons. We also have issues with confirmation bias and belief perseverance. So we talked about confirmation bias as it relates to researchers, where a researcher will be more likely to interpret ambiguous information in a way that supports their hypothesis. So we are more likely to pay attention to things that go along with a theory that we have or an idea that we have, and we're more likely to dismiss information that goes against it. And once we've made up our minds on something, we tend to stick with that. Even if we're presented blatantly with conflicting evidence, we're more likely to persevere with what we already know than to change our mind on something. So if you came into this class having already taken a psych class before, and if I said something that was completely against what your previous instructor said, you might be really reluctant to believe that. You might say, well, no, I've known it this way for years. I have to do more research. I have to look into it. You need to give me a really compelling reason to make me change. Whereas if you had no pre-existing stance, if you've come into psychology with no prior experience, you'd say, yeah, this is a pretty reputable school, and the instructor seems relatively experienced, and the textbook seems pretty valid. I would trust this, and I'll go with it. So our existing state of mind can really affect how we move forward. And then the last one is a really fun one where we have the overconfidence effect. And that is, despite the fact that we are very, very bad at judging a whole lot of different things, especially probabilities and numbers and values, we are very confident in our ability to do so. You might have been listening to me talking about, oh yeah, people are bad at estimating probabilities. You might think, well, maybe not me. I'm okay at judging probabilities. And that's another effect that we tend to have. We tend to be overconfident in things that we don't know. And we tend to feel more confident about them as we're asked about them more. So if somebody asks us, what's the probability of this? Somebody else asks us the same question again and we give the same answer, we're going to feel more certain about it. So the more we repeat it, the more we're sure of what we're saying, even if it's inaccurate. So lots of things to keep in mind when we're trying to make decisions because our reasoning has quite a few possible flaws. And I find that to be a very interesting place to leave the course because that is our last slide. But as I said last time, this was intended to finish up today. We are perfectly on time. And that means that on Friday, I'm going to show up and just sort of hang out like I did last Friday. So if you have things you want to go over, if you have topics you want to cover, bring them in. We can sit and chat. I'll have my laptop and have access to all the previous slides. But I'm not going to be preparing anything. So I'm not going to put together a review lecture or anything like that. I'm just going to be here to clear up anything that you'd like cleared up. And if you don't have anything you want cleared up, then you are fine to go, and I'll just see you at the final exam.